Hi, hello my dears, welcome back to Physics World. Good evening everyone, how are you all? Are you ready for today's class? So please do comment. So how is your school going? Is everything fine? Are you going to write the exam? Midterm exams are coming soon, right? Are you ready for the midterm exam? So you completed the revision or started the revision? So chemistry, we already completed 2 chapters, right? The first chapter and second chapter. The first chapter was solution, the second chapter electrochemistry. So today we are going to discuss about the third chapter. That's the most important chapter for our board. That is chemical kinetics. Is also a numerical chapter. In this chapter, it's very easy to learn also. We will be studying only the main topics like order, molecularity, the rate law, how to express the rate of a reaction, and the Arrhenius equation, the activation energy, and the 3 like zero order, first order, and second order half-life of the reaction. These things we are going to cover in this today's class. So are you ready, my dears? Hello everyone, hi. Hello. My voice is clear, right? Audio is clear, video is clear. Is everything okay? Please do comment. Is everything all right? Can I begin the session? Okay, so we can start the session. So the chapter, yes, hello everyone. So this chapter, what is the name of this chapter? Chemical kinetics. What is by kinetics? Now I am still, right? Am I moving? No. Now I started to move back and front, right? So what happened here? I got a kinetics. So what is by kinetics? We all are familiar with kinetic energy and potential energy, right? Okay, right. So what is kinetic energy? Just a minute. So we are familiar with kinetic energy, potential energy. What is by kinetic energy? The energy due to motion. What is by potential energy? Yes. What is potential energy? Now I am still. Did I possess any kind of energy? No, right? Why? I have a position. Due to this position, I possess an energy that is known as potential energy. Now I started to move. When I started to move, I possess one energy that is what? Kinetic energy. The energy due to motion. Like that, what is happening in a chemical reaction? The reactants react together to form a product, right? For example, how carbon dioxide is formed? How it is formed? Carbon dioxide. Carbon reacts with oxygen, it will form carbon dioxide. Similarly, what will happen? Hydrogen react with oxygen, it will form water. So, there happens a reaction. Reactants react together to form product. So, product is a new substance. Substance, what happens here? Substance reacts together and they will form a new substance, that is the product. That is happening in a chemical reaction and we can represent it using a chemical equation, right? The left side indicates what? Right side indicates what? This we already learned in our lower classes, like from 6th onwards we are learning about this, right? 9th standard also we learned it completely. We got the basic in 10th, that is balancing is there, LHS side, RHS side, everything you know. So for a chemical reaction, what is required? The reactants are required, right? Reactants react together. Yes, reactants react together to form what? Products. Arrhenius equation we will discuss in the last, that is the last topic, okay? So we can go to the chapter. Chemical kinetics means what? The rate of the reaction. So hello everyone. So the first one, what is the meaning of chemical kinetics? Chemical kinetics is the study of the rate of the reaction. This is very important. The rate of the reaction and the factors affecting it, like temperature, pressure, catalyst, and radiations is called what? Chemical kinetics is just the study of the rate of the reaction. How fast the rate is going to happen. That is the rate of the reaction. How much the rate taken. Okay, so the rate of the reaction, the study of the rate of the reaction, that is known as what? Chemical kinetics. Is that clear? Okay, then on the basis of the rate can be slow, moderate, and very fast type. We already discussed, right? We know 3 different types of reactions. Which are the 3 different types of reaction? Slow will be there, fast will be there, and moderate will be there. And the rate of the reaction depends upon which step? The slow step, right? Sometimes reversible will be there, irreversible will be there. So there is lot of different kind of reactions around us. So it is the study of the rate of the reaction that is known as chemical kinetics and depends upon several factors like temperature, pressure, catalyst, and radiation. Mainly we will learn about the 3, that is temperature, pressure, and catalyst. Is that okay? Clear, right? Okay. Then for example, we have given with an easy example, that is NaCl, sodium chloride react with silver nitrate. It will form what? Silver chloride with sodium nitrate. So fast reactions are not studied under kinetics. Why? Fast reaction will happen soon. It is very fast. So it is not studied under kinetics. That's why I told you. In chemical kinetics, the rate of the reaction only depends upon what? the slowest step, that is the slow reaction. So the rate of the reaction, that is very, very important. Noted, the rate of the reaction depends upon which step? The slowest step, not on the fast reaction, because it will occur fast. So we cannot study the rate. That's why the rate of the reaction depends upon only the slowest step. Is that clear? Okay. Then what will happen here? If we take NaCl and silver nitrate mixed in a wash glass and kept under sunlight, and it will absorb the sunlight. In the presence of the light, what will happen there? Decomposition will happen, double decomposition will happen, and the product will be silver chloride and sodium nitrate. And the silver chloride, if we dip a cotton in the silver chloride and kept under the sunlight, what will happen there? What will happen there? The color of the cotton changes to black color. Blackening will happen. That blackening is due to the formation, the decomposition of silver chloride. Silver chloride into silver and chlorine. That is happening there. So we can write the equation like this. Silver chloride, if we dip a cotton and kept under the sunlight, what will happen? AgCl is split into Ag and Cl2. What is Ag? Silver, and chlorine is chlorine gas. So this kind of reactions are fast reaction. Then rusting of iron, formation of water at room temperature, burning of coal are not studied under the kinetics. Reaction with moderate speed, molecular reactions are studied under kinetics. For example, hydrolysis of ester or sugar, that is very, very important. Is that clear? Okay, right? So we won't study the fast reaction. We will only learn about the slow step and the moderate reaction under the chemical kinetics. Okay. So we are going to the next topic. So you got the introduction about the chemical kinetics. What is chemical kinetics? It is just the study of the rate of the reaction and the factors affecting the chemical kinetics like temperature, pressure, catalyst. Okay. Then, okay. Now we can move to this next important topic. Rate of the reaction. So we are going into the chapter that is the rate of the reaction. So the rate of the reaction is defined as the rate of the change of the concentration of a reactant or a product per unit time. That is very, very important. What is meant by rate of the reaction? What is meant by the rate of the reaction? Rate of the reaction is defined as the rate of change of concentration of the reactants, or it can be the products. Change in the reaction concentration, rate of the concentration of the reactants or the products. For example, if it is reactant, we can denote it by, look here, what is C2 minus C1? Change in the concentration, that is change in the concentration. Okay, divided by change in the time, that is T2 minus T1. C2 minus C1 divided by T2 minus T1, that can be written as delta R divided by delta T. For the reactants, it is decrease in the concentration. Note it is very, very important. For the rate low, for the rate of the reaction, it is defined as a rate of change of concentration. Okay, the rate of change of concentration of reactants or the products. If it is a reactant, it is denoted by negative delta R divided by delta T. If it is product, it will be denoted by positive delta P by delta T. Why? Products concentration is increased in a reaction, right? The reactants are reacting together, it will change into what? Product. So that time the reactant concentration is decreasing, the concentration of reactant starts to what? Decrease. Same time the product concentration will increase. So the rate of the reaction increases when the concentration of products are increasing. Hello. Okay, so we can give a summary. The rate of the reaction decreases with time because the concentration of reactant decreases and the concentration of product increases. That is very, very important, that we can write like this. Rate decrease in concentration of what? Decrease in concentration of reactant with time and increase in concentration of product with time. Why I am putting a bracket, square bracket there? The square bracket indicates the concentration. Okay, this indicates the concentration of reactant and concentration of product. To determine the rate of a reaction, it is defined as the concentration of reactant or the concentration of the product in time t. And in the case of a reaction, the reactant concentration is decreasing. The rate, what happens? The rate of the reaction decreases with time when the concentration of reactants are decreasing. That is denoted by minus delta R divided by delta T, or we can write minus dr by dt. Both are same. R indicates the reactant. D means what? The small change. Negative means decrease in the concentration of the reactants with time. Is that clear? Now, how we can write the product case? Product is increasing. In a reaction, the concentration of the product is increasing, so it will be positive. So we can write like this: positive delta P divided by delta T, or positive dP by dt. So this is the indication of the products and reactants in a reaction. Okay, what is the concentration of reactant? How much is the reactant? The quantity of the reactants reacting in the reaction. Okay, that is the concentration of reactant, and it is indicated using the square bracket. Okay, then next one, the average rate of the reaction. As the rate vary, the rate is depending upon what? The time, right? It is varying with the time. So we use average reaction rate by dividing the total change in concentration of reactant or product by a time interval. That we have written now. How we will write it? Minus dr by dt is equal to C2 minus C1 divided by T2 minus T1. So what is minus dr by dt that we discussed just now? Minus dr by dt means what? The decrease in the concentration of the reactant in time t is given by decrease in the concentration, that is C2 minus C1 divided by time T2 minus T1. That can be denoted by delta T. How delta T? Delta T means what? The change in the time. So we can write the rate average. The average rate of the reaction is given by the average rate of the reaction is denoted by R average equal to minus delta R by dt. That is change in the concentration minus C2 minus C1 divided by T2 minus T1. So C2 minus C1 we can write like this only, minus C2 minus C1 divided by T2 minus C1 can be written as delta T. So C2 minus C1 means the change in the concentration of the reactant. Yes, that is important for your JE. So C2 minus C1 means what? The change in the concentration of the reactant, that we can write like minus dr. Instead of dt, delta T, we can write dt. So what is the equation? Average rate is equal to decrease in the concentration of the reactant with time. So learn this equation. It is very, very important. Equation number 1. So average rate is given by minus dr by dt. Got it? Then next one. Similarly, we can write the product also. What is product? The concentration of the product is increasing in a reaction, so it will be positive. So we can write like dP by dt. R instantaneous. R instantaneous given by dP by dt is equal to the slope from this curve. Look at the curve of this time with concentration. The curve is like this. So R instantaneous given by dP by dt is equal to the slope. So dt delta P by delta T equal to C2 minus C1 divided by T2 minus T1, and we know we can write it like what? dP divided by dt. Only this much. Clear, right? So that's the average rate and instantaneous rate. It's very, very important. It can be asked for your problems. Okay. Then next one. Instantaneous rate. Just now we discussed what's the instantaneous. At this moment, at this instant, at that time, what will be the rate of the reaction? That is known as the instantaneous rate of the reaction, and it is very equal to the very small change. Only small change in concentration will be happening, right? For example, carbon reacts with oxygen, it will form carbon dioxide. At that moment, at the 3 seconds, how much is the formation of the product? How we will find? That is the instantaneous rate of the reaction. So that is given by change in the concentration. Okay, change in the concentration during a very small interval of time. That means minute seconds will be there. So it is the equal to the very small change in concentration during a very small interval of time, that is dx, and is given by dx by dt. This already you learned in your mathematics integration and differentiation, right? So dx by dt means what? A small change in time t. Got it? A small change in time t, that is known as the instantaneous rate of the reaction. Okay, then next one. So dx by dt is equal to tan theta. It is equal to the negative slope, and it is written for any of the reactant or the production terms of the stoichiometric coefficient. Okay, so we can write like this. So give importance for this equation. Now, we are going to take another equation. Nitrogen react with hydrogen. Haber process. What will happen? Nitrogen react with hydrogen. It forms ammonia, 2NH3. It's an example. In this, instantaneous rate of the reaction is calculated. How we can calculate the instantaneous rate? This is the question for you. We are given with an equation that is nitrogen reacts with hydrogen. It is forming ammonia, that is 2NH3. Can you write the instantaneous rate of the reaction? How we will write the instantaneous rate? How we can write it? This is the method. For nitrogen, we can write, this is the equation, nitrogen plus 3 hydrogen, it forms 2NH3. So, we are going to write the reactants. First, we are going to write the reactants. So, first one is nitrogen, we can write like minus DN2, concentration of DN2 by D2. Then, how we will write hydrogen? Hydrogen, we can write like DH2 divided by DT. So, for NH3 also we can write like D NH3 divided by dt. Okay, so this is the method to write the concentrations. So, for a reactant, negative sign indicates the decrease in the concentration that we already discussed in the beginning. The reactant's concentration will be decreasing and the product concentration is increasing. That's why we are writing a negative sign in front of the dr. Like, can you see the negative in the reactants? What is the use of the negative? The negative indicates the concentration of the reactants are decreasing in a reaction and the concentration of the product is positive. Why it is positive? Because the product concentration is increasing in a reaction. Is that clear? So that is the rate of the reaction. Rate of the reaction means what? The increase in the concentration of the product or decrease in the concentration of the reactants. So for a reactant, the negative sign is indicating the decrease in the concentration. Okay, so for a reversible reaction at dynamic equilibrium, the net reaction rate is 0. For equilibrium, what is happening? For an equilibrium reaction, the rate is equal to 0. That is very, very important. It can be asked for your MCQ question for a reversible. For a reversible reaction, the dynamic equilibrium, at dynamic equilibrium, the net reaction rate is equal to what? 0. Is that okay? Clear, right? Okay, hello. Hello, Bhavani. Then, next one. Next one, the features of the rate of the reaction. The rate of the reaction is always a positive quantity. The rate of the reaction is always what? A positive quantity. It's always a positive quantity and it is proportional to the active masses of the reactant. The rate of, that is very, very important. We are going to derive the rate law and how we are going to study the rate law. Yes. Rate law, in the case of rate law, the rate of the reaction is always a positive quantity and it is proportional to the active masses of the reactant. Active masses of the reactant, we are going to derive the equation. Okay, before that, we should know how we are going to write it. And it is measured by measuring the active mass of molar concentration of the reactant or product with respect to time. How we will write the concentration of reactant? We can write like this, minus dr by dt, or if it is product, we will write dp by dt, positive dp by dt. So, it is measured by measuring the molar concentration of product or reactant. It is the rate law. So, it varies with time. It is changing with what? Time. That's why we are giving a divide it with dt. Divide with dt. Clear? So, it is better to use average reaction rate. For consider just an example. An equation is given. Na gives product. Na, it is changing into product. So, what will be the rate of the reaction? We can write minus dx by dt. The average rate is directly proportional to the concentration of the reactant raised to n. Why I am writing raised to n? Anyone knows that? Why I write here a raised to n? Why I wrote the a raised to n? You know why? What is the reason behind that? Okay. Again, we can explain that. That's very, very important. We are given with an equation. Na is changing into product P. A is the reactant. Reactants react together to form product. Now, I am going to write the average rate of the reaction, that is R is equal to. How we will write the R equal to? R equal to dx by dt. Dx by dt. And which sign I need to use here? Dx by dt, it is reactant side. So, I am going to give a negative sign. It will be equal to proportional to concentration of A raised to n. Raised to n means the power. The stoichiometric coefficient is written here. No. N means any number. It can be 2, 3, 4, 5, any numbers. raised to power I have written the A raised to N. This is the average rate of the reaction. We can write directly proportional to the concentration of the reactants. Note it. How will write the rate of the reaction? Rate of the reaction dx by dt at the moment minus dx by dt is directly proportional to the rate concentration of the reactant raised to the power. That is the stoichiometric coefficient. So we can write A raised to N. For example, you are given with 2NH3. How will you write? 2NH3 is giving N2 plus H2. How will you write the rate? We can write like this. Minus dx by dt directly proportional to NH3, concentration of NH3 whole raised to 2. Like that. This number is written as the power term. Got it? Clear? Okay. So, in a rate law, the rate is the easiest one to learn. I will give you this one. A plus BB. Just look at the general reaction. This is the general reaction. We are going to learn the rate law. That is very, very important. Important for your boards. Okay. So, we are taking a general reaction. AA plus, what is the general reaction? AA plus BB gives CC plus DD. So, what will be the rate? How we can write the rate of the reaction? The rate of the reaction, just learn this, the rate of the reaction is directly proportional to the concentration of the reactant terms. Okay, so how we will write the rate of the reaction? Rate of the reaction is directly proportional to the concentration of the reactants. If there is any stoichiometric coefficients, just write it as raised to power. Okay, just we can take one example. This is our general equation. AA plus BB gives CC plus DD. So, the rate of the reaction is given by rate is equal to, how do you write the rate? Rate is directly proportional to the concentration of reactants. Which are the reactants here? First, we need to find the reactants given in the equation. It's AA plus BB. The small letters indicate the numbers, that is the stoichiometric numbers. And A and B are the two reactants. So, how we will write? Product of A into product of B. Concentration of A into concentration of B. Here, A times it is coming. So, we want to write A raised to A. Or you can use any numbers like X, Y. Okay, that letters also you can use. I am using here A. Okay, then B raised to B. So, the rate of the reaction is directly proportional to A raised to A into B raised to B. So, that means that the rate of the reaction is directly proportional to the concentration of the reactants in the given equation. Got it? So, this is the rate. Now, we want to remove the proportionality. If we need to do a numerical, can we do with proportionality sign? No, we need to change the proportionality into equal to sign, right? So, to change the proportionality into equal to, rate equal to, we need to multiply these terms with a constant, that is proportionality constant K. What is it? K. K into concentration of A, concentration of B, A raised to A, B raised to B, or we can write K into concentration of A raised to X, any terms, any numbers, B raised to Y. This is the rate law, where K is known as the rate constant or proportionality constant. Very, very important, note it. Okay. So, how will write the rate of the reaction? Rate of the reaction is directly proportional to the concentration of the reactant raised to the powers. Some of the powers that we will learn. So, the rate is directly proportional to the concentration of the reactants raised to the stoichiometric coefficients. Now, to remove the proportionality and we need an equal to sign. To use the equal to sign, we multiply these terms with a constant K. What is K here? K is the proportionality constant. What is K? K is the proportionality constant, known as rate constant. What is K? K is our rate constant, the main of this chapter. Okay, rate constant. What is K? The rate constant. So, how we will write the rate of the reaction? Rate of the reaction is given by rate is equal to K into A raised to A, B raised to B, or A raised to X, B raised to Y, then where K is known as the rate constant or the proportionality constant. Is that clear? Got it? So, the rate constant does not depend upon the pressure, volume, concentration. Unit of the rate constant is represented as mole per liter raised to 1 minus n time, where n is the order of the reaction. And the rate constant does not depend upon the presence of a catalyst or the nature of the reactant. Note these 2 points. And rate constant K is directly proportional to temperature. That is very, very important. Rate constant always increases with increase in the temperature. For you, one question, okay. We are heating sugar in water. we take just take 2 or 3 spoons of sugar in 2 glasses of water and we are stirring it with a spoon. What will happen? 49. What will happen here? If you are mixing sugar with water with a spoon, it will take 2 or 3 or 5 minutes to completely dissolve in the water, right? The same thing I am going to keep on the stove, and I on the stove and temperature starts to increase. What will happen? When the temperature starts to increase, the sugar will easily dissolve in the water. So what happens to the rate of the reaction? Can you tell? It increased or decreased? Rate means what? How much speed? The fast rate. What happened to the rate of the reaction? Yes, tell Seema. So what will happen there? When we are heating that sugar with water, the sugar will easily dissolve in the water, right? The sugar will easily dissolve in water. Why? We are increasing the temperature. When we increase the temperature, what will happen to the sugar? The sugar starts to easily dissolve in it, right? So when the sugar starts to easily dissolve in it, what will happen there? The rate of the reaction increases. So yes, very good, very good. When temperature increases, the rate of the reaction increases. That is very, very important point. Note it can be asked for your 2-mark application level question. So the rate constant K is directly proportional to temperature. Rate constant K varies with temperature. Rate constant increases with increase in the rate constant increase in the temperature. Note it, but it does not change with the catalyst pressure or concentration. It only changing with the temperature. Temperature increases, rate of the reaction also increases. Note it. Okay, so we can go to the next topic. So this is the representation. How we will write the rate of the reaction? Rate is equal to K into A raised to X, B raised to Y. The square bracket indicates the concentration of the reactants. The concentration of A raised to X and concentration of B raised to Y. And the rate can be written as, what is the rate? If it is reactant, we will be using a negative sign to show the decrease in the concentration of the reactant. So that can be written as minus dr by dt. Look here, minus dr by dt equal to K into A raised to X, concentration of B raised to Y. Got it? Is that clear? So this is the representation of the rate law, where K is the rate constant. K is very, very important, rate constant, and K is directly proportional. K is directly proportional to temperature T. T increases, K also increases. The rate of the reaction increases and temperature is increasing. Note it. Clear? Okay. Now, so question for you. Before that, we need to learn one new term, that is order of the reaction. There are 3 different types of reaction, that is zero order, first order and second order reaction. So you know what is the order of the reaction? You already learned in school, right? Can you tell what is the order of the reaction? Order means the sum of the power of the concentration terms in a rate law. What is order? The sum of the, it's very easy to learn. Sometimes it can be asked as a definition for your exam. Otherwise, it will be in the form of this questions. And from this question, we need to find the order of the given reaction. So can we start? So order means the sum of the power of the concentration terms. Concentration terms in the rate law. In the rate law. Got it? For example, if you are given with an equation like AA plus BB gives CC plus DD. How we will write the rate law? How we can write the rate law? We can write the rate law by the equation. Just look here. Minus dr by dt. How will write? Minus dr by dt is equal to K. K is what? The proportionality constant. K, or the rate constant. K into concentration of reactant. Who is the reactant here? A raised to A. Then one more reactant is there. So we need to use a multiplication. B raised to B. Now, according to the definition of what is the order, the sum of the power of the concentration terms in the rate law. So this is our rate law. We have written the rate law. So if an equation is given, first write the rate law. How we can write the rate law? Minus dr by dt equal to K into concentration of the reactants, if there is any stoichiometric term, raised to the power. Okay, A raised to A, B raised to B. Now we are going to write the, now we are going to write the order of the reaction. Order means what? Sum of the power of the concentration terms. Here, what are the sum of the power? Concentration terms are A and B. Just look at the powers. One is A and other is B. So we can write order is equal to, how we will write order equal to A plus B, the sum of the power of the concentration terms, that is A plus B. So this is the method to calculate the order of the reaction. So similarly, we can calculate all the order for the given chemical equations. So for you, one rate law is given, only rate law, not an equation. Rate law is given K R equal to K into A raised to 1 by 2, B raised to 1 by 3. 3 by 2. This is the equation. Rate law, R equal to K into A raised to 1 by 2, B raised to 3 by 2. How will you find the order of the reaction? How we can find the order of the reaction? Just look at the concentration terms given in the equation. Who will give the answer? I will give you 1 minute time. Just do the comment. You can write the answer in the comment section. I will read the names, those who submitted the answer without any mistakes. Very easy. Just add the sum. Add the power of the concentration terms. Just add it. You will be getting the answer. Just try to do it fast. Adding powers. Yes. Do it. Just add the power. Addition of power. Yes. Just take the concentration terms. I have given you 2 concentration terms in the rate law. Just add the powers of the concentration terms. You will be getting the order of the reaction. Is it 2? Yes. We can look. Try to do. You got 2, everyone got 2? Yes, very good. Jagadish, correct. Then moon phase, Mahima. Yes, very good. Correct answer. So we can do it on the board order. First one, A raised to 1 by 2. So we can write 1 by 2 plus. Next term is 3 by 2. Just add the powers. We will be getting 4 divided by 2. Answer will be 2. So what is the order of this reaction? The order of the reaction is, if it is 2, it is known as second order reaction. What's the name of this reaction? It's a second order reaction. It follows second order kinetics. Got it? This reaction is following second order kinetics. One more question for you. Next question. You can write like K A raised to 3 by 2, K A raised to 3 by 2, B raised to minus 1. Next question, okay. B raised to minus 1. Try to do this one also. Find the order of the reaction. Next one. Got the answer? A raised to 3 by 2, B raised to minus 1. Very easy one, right? Who will find the answer? K, A raised to 3 by 2, B raised to minus 1. 1 by 2. 1 by 2 is the answer? 1 by 2, yes. So we can do, just add the powers. Which are the powers here? 3 by 2 plus minus 1. So we need to do the cross multiplication here. So what will be the answer? 3 minus 2 divided by 2. Answer is 1 divided by 2. That is 1 by 2. Yes, very good. 1 by 2 is the order of this reaction. Okay, so this is the method to find out the order of the reaction. Next, we are going to find what is a complex reaction and what is the elementary reaction. Can anyone tell what is a complex reaction and elementary reaction? A balanced reaction never gives a true picture about this, how it is happening, how the reaction is taking place. So we need to check the 2 types of reaction, that is elementary reaction and complex reaction. Elementary reaction means a reaction taking place only in one step. Only one step, not it. Elementary reaction. Now we are going to learn about the 2 types of reaction. That is, before this, there are 2 types of reaction, that is elementary reaction and complex reaction. Elementary reaction and complex reaction. Elementary reaction means taking place only in one step. Elementary reaction takes place in one step. Complex means what? It is very, very complex, right? Complex molecule means what? It's a very big molecule. Like that, complex reaction means taking place more than in one step. Like 2 steps will be the 3 steps, 4 steps. Like that, taking place in many steps. That is more than one step. So 2 types of reactions are there. One is elementary reaction, the other one is complex reaction. The elementary reaction means taking place in one step and the other one is complex reaction taking place in more than one step. Okay. Now we are going to learn about the units of the first order, zero order and second order reaction, and for that this is very important table for you. This you need to learn for your exam. Sometimes for MCQ questions the units only will be given, or a question will be given like 2.3 mole liter raised to -1 second raised to -1. Calculate the order of the reaction. Just only check the order. If the units are given, you can write which is the order of the reaction. So three types are there: zero order reaction, first order reaction, and second order reaction. For zero order reaction, the order of the reaction zero. The unit will be units that we need to use in the numerical section. That is very important. For this zero order reaction, this unit will be equal to mole liter raised to -1 second raised to -1. Liter L should be in capital letter, S is in small letter. Okay, so mole, like this you need to write mole liter raised to -1 second raised to -1 is a unit of the zero order reaction. The next one is first order reaction. That is the easiest one. For the first order reaction, the unit is second raised to -1. Second raised to -1 is the unit of the first order reaction. Then the last one is second order reaction. First zero order over, first order over, then second order reaction. For the second order reaction, the unit is mole raised to -1 liter second raised to -1, like this. Mole raised to -1 liter second raised to -1. So these three units are very important for your numericals. I will give you one question. Try to give the answer. Okay, the rate of the reaction is given. It is K equal to 2.3 10 raised to 5 liter. K equal to 2.3 into 10 raised to 5 liter mole raised to -1 second raised to -1. This will be the form of the question. Okay, a question is given here. K equal to 2.3 into 10 raised to 5 liter mole raised to -1 second raised to -1. From the given K, can you find the order of the reaction? Are we able to find the order of the reaction just from this value? Is it possible? Tell. How we can find the order of the reaction, whether it is zero order, first order or second order, from just the value? Is that possible? Is that possible? Is that possible, my dears? Yes, very good. Second order. Why to second order? Just look at the units. Here, mole raised to -1, second raised to -1 liter. Can you match out this? Look here, mole raised to -1, second raised to -1 liter. So this unit is matching this one, right? So it is second order reaction. Just look the units given in the question. If the unit is like mole raised to -1, second raised to -1 liter, it will be second order. Only second raised to -1, it will be first order. And if it is mole raised to -1, mole liter raised to -1, second raised to -1, it will be zero order reaction. And that is very important question for your boards. It is a sure question also. Clear? So from this chapter, you can expect a unit based, order based question. That is sure. And it can be for MCQ. Probably it will be for your MCQ question. Okay, done? So we can move to the next one, right? So you're clear with this units and the order. So three types: zero order, first order, second order. And what is the order? Order is the sum of the power of the concentration terms in the rate law. So we can add the stoichiometric powers, the numbers. We will be getting the order of the reaction. And for each order, if it is zero order, it's a unit, first order, second order. So learn the order and units. That's very important. Okay, then. So we can move to the next topic. That is the factors affecting the rate of the reaction. In the beginning itself, we learned what is chemical kinetics. It's a study of the rate of the reaction and the factors affecting it. And which are the factors affecting the rate of the reaction? Temperature, pressure, concentration, catalyst, radiation. Like lot of factors are affecting the kinetics of the reaction. What is the kinetics? The speed of the reaction. How much fast it is taking place. For example, we can take the previous example of dissolving sugar in water with a spoon. It will take more time, right? And if I am heating the sugar in water, what will happen there? The sugar starts to dissolve in the water easily, and it happens very fast. Why? When we increase the temperature, the rate of the reaction also increased. It takes very few time, like 5 or 10 seconds, it starts to dissolve. But if you are doing it with a spoon, it will take time like 1 minute. If you are not using a spoon, what will happen? It will take more than 1 minute, right? So there is an effect of pressure is there. If you are stirring it with a spoon, pressure is applied, so it starts to dissolve. If there is no spoon, no pressure. Clear? So there are a lot of pressure which affect the rate of the reaction, like temperature, pressure, catalyst, concentration, radiations. Got it? So these are the main factors affecting the rate of the reaction. And physical state, we know we can change from one state to other state. One physical state can be converted to the other state, right? Solid is changing into liquid, liquid into gas. How? Solid, when it heats, when absorb heat, it will change to liquid. Liquid absorb heat, it will change to what? Solid absorbs heat, changes to liquid. Liquid changes when it heat, it changes to gas, and opposite. Gas cools, it will form liquid. Liquid cools, it will form solid. That we know. So, in the physical state of the reactant, gaseous state is very greater than liquid state, greater than solid state. That is a physical state of the reactant. Decreasing order of the rate of the reaction. Decreasing order of the rate of the reaction is given. Gas greater than, liquid greater than solid state. Decreasing order, learn that gas is very high, then solid, gas, liquid, then last is the solid. Then we are going to the main topic, that is the temperature. Temperature, what will happen when temperature increases? That we already discussed. When temperature increases, the rate of the reaction also increases, right? So, for every rise of 10 degrees Celsius in temperature, the rate dx by dt increases by 2 or 2 to 3 times, or the rate of reaction increases with temperature as the number of the effective collision increases. So that we need to learn in deep. That is, for example, we took some reactants and we can mark the reactant molecules like this. So these are the reactant molecules. When we increase the temperature, when, for example, if we are heating it, if we are heating the beaker, what will happen? When temperature increases, the kinetic energy of the molecules also increases. Temperature increases, what happens to the kinetic energy? Kinetic energy of molecules increases. Kinetic energy means the energy due to motion. If you are heating a system, what will happen? When we give the temperature, when we heat the system, that molecule starts to move in all directions. For example, this molecule moves here, it moves here. In all directions, these molecules starts to move. If in the case of gas, the movement will be very fast or very high. Okay. Okay. So, when we heat it, wait a minute, I will explain it. When we heat a system, what will happen? The molecule starts to move fast and they will collide with each other. What will happen? They will collide with each other. This molecule starts to collide with each other when the system is heated, when the temperature increases. So that's why the kinetic energy increases, temperature increases, collision also increases. So they starts to collide with each other. Some molecules will be that the molecule starts to collide with each other when the temperature is increasing. So when temperature increases, what is the reason? Temperature increases, the motion, the kinetic energy is also increasing. Due to the kinetic energy increase, the collision increases. That is a collision theory of gases we already learned. So every rise of the temperature, what is happening there? When it is increasing by 10 degrees Celsius or 2 or 3 times, we are increasing the temperature. The number of the effective collision increases. Note it, the collision increases. Why the collision is increasing? When temperature increases, the kinetic energy of the molecule increases, which in turn causes the increase in the collisions. Okay. Hello, Shyam. So, which in turn increases the collision. So, temperature coefficient can be given by the equation kT degree Celsius plus 10 degrees Celsius divided by kT degree Celsius. The value of temperature coefficient lies between 3 to 2 to 3. Is that value lying between 2 to 3? Okay. Then next one. So this is the thing affecting the temperature. When we increase the temperature, what is happening? The reactant molecules moves fast and the kinetic energy increases, which in turn increases the collision of the molecules. So when collision increases, what will happen? The kinetic energy increases. So that is the cause of the increase in the temperature, which increases the rate of the reaction. Rate of the reaction increases when temperature increases. Note it, these points are very, very important. Okay, got it? Clear? Okay. The next one. So, the increase in the rate of the reaction with rise of temperature. We all know that the molecules of the reactants do not have the same energy, right? All the molecules will be having different energy. All the molecules will be having the same energy. And according to the Maxwell distribution curve for energy, the energies of the reacting molecules are plotted against the corresponding fraction, that is AN by N, at a particular temperature T, and a curve of this type is shown in the figure here. Okay. This is the figure of the plot of this Maxwell distribution curve. So just look this curve, and it is not important for your exam. It's given for your NEET and JEE syllabus one. Okay. So what will happen here? When we increase the temperature, that curve shift, like this is Tk and this is T plus 10K, and this shifting towards the right side, and but the magnitude of the threshold energy will remain the same. Okay, so what is the threshold energy? What is threshold energy, my dears? What is threshold energy? Anyone knows the threshold energy? Threshold energy is the minimum energy required, right? So next one is a negative temperature coefficient. It is observed in the case of 2NO plus O2 gives to NO2. For this reaction, we are having a negative temperature coefficient, and the graph is given like x-axis, y-axis, rate is the temperature is there, and this negative temperature coefficient. The graph will be like this. Okay. So this will be asked for 1 mark. Okay. We will be going for the organic after the 2 more chapters are there, like D and F and coordination. After we will be going to the haloalkenes and haloarenes part. Okay. Clear? How to prepare this chapter for your second terms? For your second term also, the complete chapters will be there from the starting to ending. That is a total 10 chapters will be there for your boards. So all chapters are having the same, like almost same weightage, like 7 to 8 weightage will be there. So you need to consider this term, this chapter for the second term also, if you are preparing for the CBSE boards. Okay, for the second term also it will be there. That means your boards, the final boards. Okay, clear? Then next one, the concentration. The rate of the reaction is directly proportional to concentration. That is very, very important. You need to concentrate mainly on the temperature, concentration, pressure and catalyst terms. Okay, so in the case of concentration, the rate of the reaction is directly proportional to concentration, and we can write like dx by dt. What is dx by dt? The rate of the reaction. Rate of the reaction dx by dt is directly proportional to concentration C. That means concentration increases, the rate of the reaction also increases. Okay. It is for 12. Some topics are also related to NEET and your JEE syllabus. That's why it is coming in between, like the Maxwell distribution curves and the other things related to that. So mainly concentrate on these kind of topics like temperature, concentration, pressure, then catalyst, radiations. Okay. So this one is for your boards. So the rate of the reaction dx by dt is directly proportional to the concentration. That means the concentration increases. What happens to the rate of the reaction? Rate of the reaction also increases. Clear? And in the beginning, we discussed about the rate of the reaction, the rate law. How we wrote that? Decrease in the concentration of the reactants with time t, or increase in the concentration of the product. Reactants will be completely changing into product in the chemical reaction, right? Reactants react together and it is changing into product. Okay. So concentration of the reactants are decreasing and the concentration of the products are increasing. That is happening in a chemical reaction. Got it? So the rate of the reaction is directly proportional to the concentration. Then next one is pressure. For pressure also, the rate of the reaction increases. That is dx by dt is directly proportional to pressure, as pressure is directly proportional to concentration. Concentration increases, pressure increases. And we know what happens when we are dissolving a gas in a liquid. If we apply a pressure, what will happen? It will easily dissolve. For example, we filled this beaker with some kind of liquid and we pumped some gas on the top. Gas molecules are here and liquid molecules are also there. Liquid molecules. We need to dissolve this gas into the liquid. Is that possible? By simply shaking? Somewhat, to some extent, we can mix the gas with the liquid. If we are applying a pressure on the top of the gas, if you are applying a pressure on the top of the gas using a piston or some other machines, what will happen? The gas starts to easily dissolve in the liquid. So what will happen here? So liquid, gas will be there, liquid, gas molecules, then liquid molecules. So look here, look the picture, what is the difference? The gas started to dissolve in the liquid. The gas dissolved in the liquid when we apply the pressure. So it came, that is the in the chapter solution we discussed, right? When pressure increases, the solubility increases. Same example we can take here also. The rate of the reaction increases when we apply the pressure. That is, the rate of the reaction is directly proportional to pressure. Pressure increases. Rate of the reaction increases, pressure increased. Got it? Clear? Okay, then next factor we can, the surface area. In the case of heterogeneous reactants, the greater the surface area, faster is the rate of the reaction due to the presence of more number of active sites. That means when the surface area is increasing, that is very, yes, very good. Very important thing, that is surface area. For example, if we are dissolving sugar, water, we have taken water in this beaker, water is filled, okay, and in this I'm going to add a piece of sugar in a crystal form, a big piece of sugar. The same thing I'm going to take in another beaker, same amount of water I have taken. In this beaker I'm going to add crushed sugar, okay, or completely grinded sugar I'm going to add in the form of white powder. So this white powder will be fully covering the down portion of the beaker. Everywhere it will be what? The white powder crystals. Okay. Now, can you tell in which case the reaction rate will be very high? It's very easy. Can you tell in which case? Very easy thing, right? In beaker, I have taken water and a piece of sugar in the form of a big crystal is added to it. And the other beaker with the same amount of liquid, I have added sugar, grinded sugar and like a white powder. In which beaker the sugar will easily dissolve? And what is the reason for that? Can anyone tell the answer? What will be the reason? And which beaker we can see the rate of the reaction fast? Faster reaction will be happening in which beaker? First or second one? In the first beaker, the sugar crystal is very big, right? So it will take more time to dissolve in this water. Yes, very good. In the second beaker, just look here, in the form of like minute particle. It is grinded and it's completely very small. And it's completely spread on the bottom portion of the beaker. Here, this portion, the sugar molecules is completely spread. That is, the surface area is more for this sugar. Here what happened? The surface area increase. The area occupied by the sugar. Here only this much area is occupied, right? This much area is occupied, but in the case of sugar, grinded sugar, this much surface area is occupied. So the reaction happens quick here. The rate of the reaction will be fast in the second beaker because the surface area is very high. When surface area increases, the rate of the reaction is also very sugar. Yes, grinded sugar, but surface area increases when the rate of the reaction also increases. Clear? That is very important topic. Noted. Surface area increases, the faster the rate of the reaction due to the presence of more number of active sites. And the same example we can take for our HCl and calcium carbonate. In this beaker, it is filled with HCl, hydrochloric acid, dilute hydrochloric acid. Okay, now I am going to add a piece of big calcium carbonate. We can add calcium carbonate. What will happen here? When calcium carbonate react with acid, we know the reaction, right? Some kind of gas will come out from this. And in this beaker, we can see which gas is coming out? CO2 gas will be coming out. The same thing I'm going to add in the other beaker, same amount of dilute HCl. To this, I'm going to add powdered. What is it? Powdered calcium carbonate. What will happen in the second beaker? The amount of carbon dioxide will be more here. Like lot of carbon dioxide molecules will be liberated from this beaker. Why? The rate of the reaction is more here because this much surface area. This is the surface area. The bottom portion of the beaker will be completely covered with the powdered calcium carbonate. That much surface it is taken by the calcium carbonate. So the rate of the reaction will be very high for the second beaker. In the case of first beaker, it is a very big molecule. Only this much surface it is taken. So the reaction takes place slow. Only little of the carbon dioxide gas is liberated from this first beaker. But in the case of second beaker, it is powdered or grinded. So the reaction that much active sites, these much powders are there. So HCl can easily react with the powder calcium carbonate. So lot of carbon dioxide gas will be eliminated or liberated from the second beaker. So from this experiment itself, it is very clear that the surface area increases. What happens? Surface area increases. What happened to the rate of the reaction? Rate of the reaction also increases. Rate of the reaction is increasing. Got it? Clear? Okay. Then, next one, the nature of the reactants and products. The nature of the reactants that we are using for the reaction. So, for ionic reactants, the rate of the reaction is very fast. For the ionic reactions or the reactants, the rate will be very fast as the activation energy is 0 for this. And molecules have a slower reaction rate and they require high activation energy as they require high activation energy. For molecules, they have slower reaction as they require high activation energy. For ionic reactants, noted, it can be asked for you 1 mark. For ionic reactants, the rate of the reaction is fast as the activation energy is 0. Then next one is radiation. Radiation, just we don't want to give lot of stress for this topic. The main topics are only temperature, pressure and concentration, and catalyst is also coming. Then next one is the radiation. Radiation for a photochemical. Radiation means what? The form of light energy, right? Lot of form of radiations are there. Like UV is there, X-ray is there, gamma is there, like that. Sunlight is there. And sunlight is the main form of radiation, right? In that itself, like a lot of electrochemical series we know. So, lot of radiations are there. And for a photochemical reaction, what happened when light is coming and it is helping for the reaction in the form of light energy. When light is absorbed, the rate of the reaction, what happened? Increases. Why? It is the form of heat energy. Temperature is increasing. Temperature increases. Rate also increases. That is the relation. Rate increases when radiation is increasing. So, dx by dt is directly proportional to the intensity of radiation. Dx by dt means what? The rate of the reaction is directly proportional to the intensity of the radiation. So, the rate of the reaction for a photochemical reaction depends upon the intensity of light radiation and is increased by absorption of photons. What is meant by photons? Photons are the small energy packets of lights. So, when the photons are increased, it increases by the absorption of photons. When the absorption of photons are increases, when more photons are coming, light energy is more, what will happen? The reaction rate is very, very high. They are directly proportional. So, the rate of the reaction increases when the radiations are increasing. Radiation means what? The photochemical energy. That is the light energy. Radiation increases. Got it? Clear? So, next we can move to the main factor affecting the rate of the reaction, that is catalyst. There are two types of catalyst, positive catalyst and negative catalyst. Positive catalyst means what? Which increases the rate of the reaction. Negative means what? It will decrease the rate of the reaction. They are also known as promoter and poison. Have you heard about promoters and poisons? Promoter means what? Promoting, increasing the rate of the reaction. Poison means what? Decreasing the rate of the reaction. So, first one is the positive catalyst. Positive catalyst which increases the rate of the reaction by providing an alternate path which requires a lesser activation energy, which require only lesser activation energy and provides another path for the reaction to be carried out. And it does not take part in the reaction. And we can separate the catalyst. It won't interfere the product formation. It just help to increase the rate of the reaction without participating in the reaction. That is very, very important. Catalyst won't participate in the reaction. It just only help to increase the rate of the reaction. Okay. By giving another path for the reaction to be carried out and which decreases the activation energy. Okay. Is that clear? So, a negative catalyst. Next, first one is positive catalyst. The other one is negative catalyst. First one. Next one is negative catalyst. What is my negative catalyst? Just the opposite. This one is promoter. A positive catalyst is also known as promoters. And the other one is poison. Poison means a negative catalyst. A negative catalyst. Okay, welcome. So, a negative catalyst means which decreases the rate of the reaction without participating in the product formation of the reaction, just which helps to decrease the rate of the reaction, and catalysts are more effective in solid powdered form, which is providing a greater surface area, more number of active sites. That's why we are using catalyst mainly in which state can be asked for 1 mark. There are two types of what is catalyst. Catalysts are the substance which is used to increase or decrease the rate of the reaction. Note it, it can be used to increase or decrease the rate of the reaction. And there are two types of catalyst. One is positive catalyst and other is negative catalyst. Positive catalyst in which helps to increase the rate of the reaction. So they are also known as promoters, increasing the rate of the reaction by providing an alternate path, lesser activation energy. Then just the opposite, that is the negative catalyst. Negative catalysts are also known as poison, which help to decrease the rate of the reaction by increasing the activation energy. That means what? They will be used in the form of more activation energy form is used in the case of negative catalyst, that is poisons. And if it is negative or positive, the catalyst is used in the solid state. Why? In the solid state only, solid powdered state only, more surface area will be there. We know, like the last example, if you have taken the calcium carbonate in the powdered, solid powdered form, what will happen? It will be totally covered in the top portion, the bottom portion of the beaker. So the surface area occupied by the calcium carbonate is more, right? So when calcium carbonate surface area increases, the reaction is taking place fast. That means the rate of the reaction is increasing. So surface area increases, the rate of the reaction also increases. That's why the catalysts are always taken in the solid powdered form, which helps to increase the active sites and which increases the rate of the reaction. Is that okay? Clear? So this is very, very important. The catalyst section is very important. It can be asked for the 2 marks, and you need to learn the examples for promoters and poisons. Okay. Then next one is just a minute. We can go to the next topic. Next one, increase temperature of reactants. What is happening when we increase the temperature? What happens to the reactant? This section we already discussed. Again, we can go to the what is happening in the temperature section. Increase in the temperature, what will happen? The kinetic energy of the particle increases, which increases the frequency of the particle collisions. And what is happening when temperature increases? As I told before, the molecules. For example, if you have taken a gas in a container, when we heat it, what has happened? Or air in a balloon, and when we kept under the sunlight, what is happening? The kinetic energy of the gas molecule is increasing. When kinetic energy increases, they start to move fast. When they move, the molecules start to collide with each other. Due to the collision, the number of collisions per unit time or the frequency of the collisions of the particles increases, so the rate of the reaction increase. Okay, so like that, when we increase the temperature in a reaction, the particles present in the reaction increases the kinetic energy and the frequency of the collision increases, and the greater proportion of collision will have a sufficient energy required to react. So this is the room temperature. First graph for the room temperature. This is the graph, and this is the frequency of collision. Particles with energy required to react is given in the green color. Now, when we increase the room temperature by 20 degrees Celsius, when we are increasing the temperature of the room, what is happening here? Look at the curve. This blue curve, like this. It is increased. Particles with energy required to react, it is increased. Okay, so the frequency of collision is also increased. That is the difference between the room temperature and increased temperature. So next one is increase in the surface area. We know that if you are taking a square, the surface area is very low. Only this much surface it is occupied. So surface area is low, rate of the reaction is decreased. So when we divide the square into different pieces, like we got 8 squares, what is happening? These much areas are occupied by the small squares, right? So the surface area increases. Surface area increases, the rate of the reaction also increases. Just the summary of the previous topic. Okay. Then next one, this pressure of the reaction. Same example we discussed, right? We have filled a liquid in a beaker. On the top of the liquid, a gas is pumped. Or just think about the soda water. And what is happening when we apply a pressure on the top of the liquid? What happens? Its dissolution, solubility increases. The gas starts to dissolve in the liquid easily. So when pressure increases, what happens? Rate also increases. Concentration increases. Concentration increases, rate of reaction also increases. So that is the effect of the pressure. Increasing the pressure involves gassing. Gas is the force of attraction. What happened to the force of attraction? And the force between the particles, what will happen? They will move closer and they will start to dissolve, and which will increase the frequency of particles collision, therefore increases the rate of the reaction, like we already discussed in the previous thing. Then catalyst also same thing. What is a catalyst? Which increases the rate of the reaction. 2 types of catalyst, positive and negative. And catalyst is an alternative route for the reaction with a lower activation energy. Okay, and this means that the particle collision needs less energy in order for a reaction to occur, thus increasing the rate of the reaction. Catalysts mainly help to increase the rate of the reaction. So if it is increasing the rate of the reaction, just look, reactants are changing into product, and E is the activation energy. without catalyst. Look here, red color indicate without the catalyst. So this is the energy, this is the reaction progress, this is the curve. Okay, changing to product. Now we added a catalyst to this reaction. If we added a catalyst, just look the blue line, this is the EA, an activation energy with a catalyst. Only less energy is required. Look here, where it is, this is the point. Okay, when we are using a catalyst, the activation energy, what is activation energy? The energy required for the reaction to be carried out, that is EA. Here, the activation energy is low compared to this curve. This is a transition state, this is the transition state. Here, the EA is very low compared to without catalyst. Red is without catalyst, blue is with catalyst. When we added a catalyst, the activation energy is decreased. So, the rate of the reaction is increasing in that reaction. Clear? The next one, use of a catalyst in a reaction. There are two types of catalyst, negative catalyst and positive catalyst. Positive catalyst means what? Shortening the activation energy by increasing the rate of the reaction, that is known as promoters. And negative catalyst means increasing the activation energy, slow downing the reaction. That means rate of the reaction is decreasing by increasing the EA. So note it, these things we already discussed just 3 or 4 slides before. Okay, got it? Hello. Then next one is the collision theory. Collision theory is very, very important. In the collision theory, a reaction takes place when the reacting molecules undergo collision. Why a collision is happening and how it is happening? We know that when temperature increases, the molecules will stay like this. Are they stay like inert, like a noble gas? No. What is happening? When temperature increases, the molecule starts to move in all direction. When they move to start in all direction, they will collide with each other. When they collide with each other, what will happen? When they collide with each other, the kinetic energy increases, temperature increases, the frequency of collisions also increases. Okay. So, when the collision increases, the reaction rate also increases. That is the collision theory we are going to learn. For effective collision, the colliding molecules must have a sufficient kinetic energy. For a collision also, the energy, there should be a minimum energy, you know, like a threshold energy. What is threshold energy? The minimum energy required. Yes, Aryan. So, there should be a minimum kinetic energy. There should be a minimum threshold energy to take part in a reaction. Like that, for effective collision, a colliding molecule must have sufficient kinetic energy. What is sufficient kinetic energy? The energy due to motion. So, for that purpose, if we are increasing the temperature of the molecules, for example, we have taken some gas in a beaker. When we increase the temperature, what will happen? The molecule starts to move. So, there should be a minimum energy, then only the molecules starts to move in all direction and they starts to collide with each other. Otherwise, they won't collide. There won't be sufficient energy, they won't collide. So, there should be a sufficient kinetic energy or then sufficient colliding energy, sufficient kinetic energy for the collision of the molecules. So, collision should be properly oriented. That collision should be what? Properly oriented. So, this is the picture depiction of the collision. For example, first you have taken a molecule. What happens? When the temperature or the activation energy is increased, the activated complex formation, they starts to separate. So, it forms the product. So, this is effective collision, and ineffective collision, it will be like this. Effective collision, the products will be like this only. Okay, clear? So, collision is very, very important. That's why it is repeatedly coming in the other slides also. So, the next one, what is a threshold energy? And this can be asked for your 1 mark sub question. Threshold energy is the minimum energy required to convert a reactant into product. And in a chemical reaction, we know that reactants are changing into what? Product. If we want to change the reactants into product, there should be a minimum. No, sorry, this will be completely in pure English. This is not Hindi, okay? So, to convert a reactant into product, if we want to change reactants into product, we need a minimum kinetic or the minimum amount of energy. The minimum amount of energy needed to convert reactants into product is known as what? The threshold energy, and this is the minimum amount of energy possessed by the reacting molecules to have effective collision for the formation of product. Okay, so this is very, very important. What is threshold energy? Threshold energy means the minimum amount of energy required for the reactants to change into product. So, what is happening there? Reactants, the same example we can take in the beaker. The reactants will be there. They will start to move. They will collide with each other, and they will collide with each other and they will form the product. So, for forming the product, they require a minimum collision. That means the minimum energy is required. Without the minimum energy, they cannot collide with each other. So for the minimum collision or the minimum threshold energy means the energy required for the collision. So which collision increases, the temperature increases, rate of the reaction increases. Got it? So the reactants are changing into product. For changing the reactants into product, they require a minimum energy. That is minimum kinetic energy or the minimum energy required to convert product reactant into product is known as threshold energy, and the minimum amount of energy possessed by whom? The minimum energy possessed by the reactants to change into product. Okay, the minimum energy possessed by the reactants to change into the product is known as what? The threshold energy, and they should have a minimum energy, then only it can change into product by the effective collision. Here also the collision is coming, so note it is very important. Okay, the next one, next one is making chemical reaction happen faster. There are a number of different things that we can change to make a chemical reaction faster, right? So a lot of chemical reactions are happening around us. For example, the spoiling of milk. What will happen if we keep the milk overnight? Tomorrow, what will happen to the milk? It changes into curd. Curdling will happen. And if we want to make the milk, we want to make the curd very fast, we can just add a drop of vinegar or just add a spoon of lemon juice. It will be changing into curd very fast. The same thing, we can keep it overnight. Tomorrow or day after tomorrow, it will be changed to curd without adding anything. So there are two types of reaction. We can make a slow reaction or fast reaction. So how we can make a chemical reaction happen faster? There are different ways we can make a chemical reaction faster, and we can explain the concept of collision theory and how it can be used to explain the effect of 5 different factors on the rate of chemical reaction. So which are the 5 factors we already discussed? Temperature, pressure, concentration, catalyst and radiation are the 5 factors affecting the rate of reaction. Surface area. Surface area is also there. Surface area is very important. Okay, clear? Then next one. So collision theory. What will happen? The molecules will collide with each other. Then products insufficient energy, they won't collide. So there is a sufficient energy or the minimum energy required for collision. They won't collide if they are in opposite orientation, or there is no energy, they won't collide. Okay, clear? Okay. So collision theory states that for a reaction to occur, particles must collide. Note it. Again, we are discussing this collision theory because collision theory for the collision, it requires a minimum energy. The particles, the reactants require a minimum energy to change into product. A minimum frequency is needed for changing into product. And if the molecules are in different orientation, the collision won't happen. And if there is no sufficient energy also, the collision won't happen. They lose mass? No. So, collision theory states that for a reaction to occur, particles must collide with the correct orientation and with sufficient energy, and the different factors affect the rate of the reaction by affecting the frequency of the particles collision and proportion of collision that have enough energy to react. Okay, then increase concentration of the reactant. This is very important thing. The concentration of the reactants and products. So, what happens when we are increasing the concentration of the reactants? Can you tell? It's very easy thing. If you are adding more concentrated, in one beaker, we took dilute HCl, and in other beaker, we took concentrated HCl, we added powdered, this is a powder, okay, powdered calcium carbonate, and this one, powdered calcium carbonate, both. In which beaker we can see more carbon dioxide coming out? In which beaker we can see more carbon dioxide coming out, in dilute HCl or concentrated HCl? And can you tell the reason behind that? What will be the reason behind the reaction happening? It's very easy. In the case dilute HCl, it is more water and little of HCl. But in the case of second beaker, it is concentrated HCl. The concentration of the reactant is very high. Concentrated HCl means the reactant concentration is very high. When the concentration of reactants are more, the collision between the particles will be also what? More. When collision increases, what happens? The rate of the reaction is increased, and that's why the increased concentration of reactants increases the rate of the reaction. Increasing the concentration of reactants in solution increases the rate of the reaction. There are more number of particles. Note, it's very important. If you are increasing the concentration of the reactants, if you are increasing the concentration of the reactants, what will happen? The rate of the reaction increases. Why? The particles are increasing, the collisions also increase. Frequency of collision between the particle increases. Very important. Note it. Then next one, according to this theory, the collision theory, the rate is given by F into Z, where F is the fraction of the molecule with potential energy greater than threshold energy, and F we can give by FEA raised to F is equal to E minus EA by RT, where E is the activation energy, R is the universal gas constant, T is the temperature, and P is the orientation factor, Z is the collision frequency. And activated state of transition energy is given by this one. This is very, very easy. Just look. We have taken hydrogen gas and iodine. That means H2 is going to react with iodine. We can look what is happening here. Okay, so what is happening here? Hydrogen is reacting with iodine. We are mixing hydrogen and iodine. What will happen there? They will start to collide with each other, right? When the particles are mixed together, they will start to, when the reactants are there, the reactant starts to collide with each other and they will form a transition state like this. HH is there. H and I will form a transition. HI. Then between the H and I, they will form a partial bond. So this is the transition state. We know that the transition state is stable. No, it is not stable. So the transition state will suddenly break and it will form like this. HI plus HI. Look here, we got the product. HI plus HI. And we know the final reaction. What is happening here? H2. Hydrogen react with iodine. What is the product? It is 2HI. We got it. So by the collision we are getting CBSE board. Okay. So hydrogen reacts with iodine. It will form hydrogen iodide that we already know. And what is happening inside that we don't know. That we can draw like this and show. We took hydrogen H2 and iodine, and when they start to react, what will happen? HI will be formed like this. HHII, H and I will form a partial bond. Bond formation is happening between H and I due to the collision between the hydrogen and iodine molecule, and it is a transition state, it is unstable, it will break and it will form HI, 2HI molecule. So we can write like this, H2 plus I2 gives 2HI. This is the form of the collision happening in the molecule. Got it clear? Okay, so we can move to the next topic. The activation energy. What is activation energy? We are telling from the beginning, activation energy. This is activation energy. Minimum activation energy is the maximum activation energy. Positive catalysts have low activation energy. Negative have high activation energy. Like that. What is activation energy? Activation energy is denoted by EA. E activation, E is the energy. And it is a minimum amount of external energy or the minimum extra energy needed to change a reactant into product. What is it? The minimum energy required to change a reactant into product or to make potential energy of the reactant equal to the threshold energy, and it is denoted by EA. So what is activation energy? The minimum energy required to change a reactant into product is known as the activation energy, and it is like threshold energy only, denoted by EA. So EA equal to threshold energy minus the potential energy of the reactants or average kinetic energy of the reactants. So the rate of the reaction is inversely proportional to activation energy. That means the rate of the reaction decreases when activation energy increases. That means that much energy is required for the reaction to be carried out to change the reactants into product. What is my activation energy? The energy required to change the reactants into product. So if the activation energy is more, that means that much rate, that much time is taken to convert the reactants into products. Activation energy is very high. So it requires more energy to convert the reactants into product. That means the reaction rate will be slow. So the rate of the reaction is inversely proportional to activation energy. Rate increases when activation energy decreases. Is that clear? So positive catalyst increases the rate, activation energy decreases. Connect and learn, so it will be useful for you. Okay, so the rate is inversely proportional to the activation energy, or inversely proportional to EA. Hence, the lower the value of activation energy, faster will be the reaction. EA low, rate will be high. Only that much. Clear? Then. So this is the graph showing reactants changing into products. Not reaction, reactants. Okay. Reactants reactants is changing into product, and the reactants, they will form a transition state like the HI we have drawn now. H2 plus I2, HII, like that a transition state is formed, and in the transition state, so activated complex it will suddenly change into product to form the transition state from the reactants to reactants. To change the reactants into the transition state, the energy required is known as the activation energy. Okay, it's changing into product. Then we are going to the Arrhenius equation part. Arrhenius equation is used to evaluate the energy of the activation and show the effect of temperature on the rate constant. Arrhenius equation. Arrhenius have given an equation which connect the relationship between the temperature and the activation energy. So there is a relation between the temperature and activation energy. This is the equation used to find the relation between the temperature and activation energy, and to evaluate the energy of activation and show the effect of temperature. Note it, only this equation which shows the relation between temperature and EA. What is Arrhenius equation? Which shows the relation between temperature and the activation energy EA, and how it is given. Arrhenius equation used to evaluate energy of activation and show the effect of temperature on rate constant, and K equal to AE raised to minus EA by RT. Yes, so we can write the equation like K equal to AE minus EA by RT. AE raised to minus EA by RT, where A is the Arrhenius constant. What is E here? E raised to minus EA by RT represents the Boltzmann factor. That is very, very important. Note it, A as the Arrhenius constant, and we can write K equal to AE raised to minus EA by RT. A Arrhenius constant, and EA is the activation energy. R and T, we know T temperature, R is the universal gas constant, and E raised to minus EA by RT is the Boltzmann constant. And what is small letter e? It's exponential. What is the opposite of exponential? It is log. We already learned in maths, right? Okay, so E is exponential, A is Arrhenius factor, E is activation energy, R and T are the constants. Okay, so learn this term, it's very, very important. E raised to minus EA by RT is the Boltzmann factor, and A is the Arrhenius factor, other name pre-exponential factor or the frequency factor, and it can be asked for MCQ, the three names of Arrhenius: pre-exponential factor, Arrhenius factor, and one more name is the frequency factor, and E raised to minus EA by RT is the Boltzmann constant. And this is the only equation which shows the relationship between the temperature and the activation energy. Yes, this is chemical kinetics. Okay. Then next one, when EA is 0 or the temperature is infinite or infinity. So what happened to the equation? We can write, we know the equation, that is K equal to EA raised to minus EA by RT. What is the equation? K equal to AE raised to minus EA by RT is the equation. Now, what happens when EA becomes 0? When EA equal to 0, the final equation will be K equal to AE raised to 0. E raised to 0, what is E raised to 0? E raised to 0, we know it is 1. So, the final equation will be A. K equal to A. A signifies the frequency of binary collisions or the total number of collisions per unit volume per unit time. So, at two different temperatures T1 and T2, this is the equation that we are going to use for our numericals. Okay. So, according to the Arrhenius equation, if there are two temperatures T1 and T2, and we can write the EA as EA equal to 2.303 R T1 T2 divided by T2 minus T1 log 10 K2 by K1. Or the final equation we can write like log A by A minus X equal to EA by 2.303 R T2 minus T1 divided by T1 T2. This is the final equation, or we can calculate the activation energy. We can calculate the activation energy using the equation 2.303 R T1 T2 divided by T2 minus T1 into log 10 K2 divided by K1. Okay, clear? So these two equations are very important. Use it for your numericals and note it, write it down. It's very important for your numerical session. Okay, then next one. Graph between log 10k and 1 by t. And this is the two graph showing the relation between the log 10k and 1 by t. When we plot a graph between log 10k and 1 by t, a straight line with a negative slope is obtained. A straight line with a negative slope is obtained and is equal to EA by 2.303 r, that is EA equal to minus 2.303 r. Here the intercept is equal to log 10a. Then elementary and complex reaction that we already discussed in the beginning. And elementary and complex reaction, what? Tell. What do you need? So in the case of elementary and complex reaction, we know that the reaction occurring only in one step is known as elementary reaction. Sometimes it can be asked for the comparison question like what is elementary and the complex reaction and differentiated with an example. It can be asked sometimes only for 2 marks. So elementary reaction means a reaction which occur only in one step is known as elementary reaction and is provides that with the desired products, and this reaction are termed as complex. When it is complex, when it is happening in 2 or more different steps. So such reaction can be consecutive, reverse or side reaction. In the complete combustion of alkene, the final products are always carbon dioxide, water, heat and light. However, during this reaction, a series of elementary reaction takes place, during which is alcohol, aldehyde, acids are formed. Sometimes there will be 2 types of reactions: elementary reactions and complex reaction. Elementary means what? Only happening in one step. Complex means if the reaction is happening in 2 or like 2 or more, 5 or 6, 7 steps. Yes, we will be providing a formula sheet, then it will be useful for you. Okay. Yes, good evening. So then it will be useful for you. You can just revise the formulas and it is useful to apply in the numericals also. Okay, that you will get. Just follow this channel. Okay, right? So if it is complex, like many steps will be there, and not only in many steps, and each steps different products will be there. So like that, if the reaction is happening in, thank you. If the reaction is happening in many steps, then it is known as what? Complex reactions. Okay. Then next one is molecularity. We have discussed the order of the reaction. Similarly, the same like molecularity also is very important. It can be asked for your 2 mark. This chapter is approximately like 7 to 8 weightage chapter, and from this 1 mark we can expect for the order and 1 mark from the molecularity section. Molecularity means the number of the reactants participating in the reaction is the number of the particles that must collide with one another simultaneously, which result in a chemical reaction. That means the number of reactants participating in a reaction. For example, I have given you reaction H2 plus I2, it forms 2HI. So can you tell the molecularity of this reaction? This is the example. Hydrogen plus iodine, it forms 2HI. So can you tell the molecularity of the reaction? How we can explain the molecularity? Molecularity means the number of particles reacting, number of the reactants in this reaction. So we can count the number of the hydrogen. How many hydrogens are there? Nothing is written, so it means 1 molecule. Here also 1. So total 2 reactants are there. So the molecularity of this reaction is what? 2. 1 plus 1, it will be equal to 2. 1 plus 1 equal to 2 is the molecularity. So molecularity shows the reactants reacting in a chemical reaction to form the product. Got it? Okay. So it is always a whole number. It's a theoretical value. It's not an experimental value. It's just a theoretical value, and it shows the, it is only in the form of a whole number, and it never determines the rate of the reaction. It won't interrupt in the rate of the reaction. It does not show the rate of the reaction. Okay. And it never depends upon the external factors like temperature and pressure. It does not depend upon the rate of the reaction, does not depend upon the temperature, pressure, and molecularity cannot be more than 3, as there is nearly no chance for more. It cannot be more than what? 3. And in a multi-step reaction, the molecularity is determined separately in each step. For example, if it is a complex reaction, many steps will be there, and in many steps different reactants will be reacting. So we need to calculate the molecularity for each step in a kind of complex reaction. Then in case of complex reaction, the slowest step is called the rate determining step or the rate limiting step. That is very important. In the beginning itself, we learned that we won't check the rate of the faster reaction. Only we will learn about the rate of the slow steps or the moderate one. So that is the meaning of the thing. The slowest step is the rate determining step. Note it's very, very important. Slow step. Slow step is the rate determining step. Rate determining step. Not the fast step. Chemical kinetics, we are not learning about the fast reaction. We are giving importance for what? The slow step, and the slow step is the rate determining step. Okay? Is that clear? Then next one. Molecularity. For example, another example is given. The overall molecularity of a complex reaction is equal to the molecularity of the slowest step. Already discussed. The molecularity of a reaction is 1. The reaction is called unimolecular. That is very, very important. If you are getting the value 1, that kind of reaction is known as unimolecular. If it is 2, it is known as bimolecular. If it is 3, trimolecular. Okay, clear? Okay. So, okay. So, just count the number of reactants. For example, it is PCl5 gives PCl3 plus Cl2. Here, how many PCl5 molecules are there? Only one is there, no. So, what will be the molecularity? If there is only one molecule, the one reactant is there, the molecularity will be equal to 1. If the molecularity is 1, it is known as unimolecular reaction. If molecularity is 2, what is the name of that reaction? If molecularity is 2, it is known as what? Bimolecular reaction. If it is 3, it is known as trimolecular reaction or trimolecular reaction. We can trimolecular. Okay, trimolecular reaction. For example, here given with the 2 example, C12H22O11 plus H2O. How many reactants we use here? 1 sugar and 1 sucrose and 1 water. That means 2. So if 2 reactants are there, the molecularity will be what? 2. So it is bimolecular reaction. The next one, 2 FeCl3 SnCl2. 2 plus 1 SnCl2. So total how many reactants we use in this reaction? 3 reactants. 3 reactants means what? Yes. Okay. So 3 reactants means 3 reactants are participating in the reaction. So the molecularity of the reaction will be 3 trimolecular reaction. Got it? Clear? Okay. So next one, order we already discussed, right? What is order? Order is the sum of the power of the reactants. Sum of the power of the concentration of the reactant terms in the rate laws known as the order of the reaction. For example, if it is written like rate is equal to A raised to M, B raised to N, what will be the order? Till we already discussed, we have done 3 questions related to the order of this reaction. How we can find the order? Order means the sum of the power of the concentration terms. Here the 2 concentration terms are A and B. What are the powers? M and N are the powers. So we can write like M plus N is the order of the reaction. It is 1 plus 2, 3. 3 plus 5, what will be the answer? 8. Like that. So order means the sum of the power of the concentration terms, and it can be 0, negative or a fraction. It determines the rate of the reaction. It determines the rate of the reaction. Molecularity doesn't determine the rate of the reaction, but order depends the determines the rate of the reaction. Clear? There are 3 types: 0, first order, second order. We already learned the units of 0 order, first order and second order reactions. Is that clear? Okay, done. Then next one. It depends upon temperature, pressure and concentration. Order of the reaction depends upon the temperature, pressure and concentration. Anything present in excess is not counted at the order of reaction. For example, in hydrolysis of ester and sugar, water is excess, so it is neglected for the order. And order of any reaction is determined by the slowest step. Order is also determined by the slowest step. So the rate determining step is the slowest step, and order is also determined by the slowest step. Note it, it is very, very important. And high order reactions are rare due to less chances of effective collision. Higher order reactions are very rare. Because, what is the reason? Because of the rare chance of the effective collisions of the molecules. Okay, so mechanism is given here. What is just an example for you guys? So ozone, O3 is taken. What happened to the O3? O3 is changing into oxygen plus nascent oxygen, and it's a very fast reaction. In the second step, this O3 again reacts with the nascent oxygen. It forms 2 oxygen, and it's very slow step. That's why in our atmosphere, what is happening? The oxygen cycle or the oxygen level of oxygen is maintained or the stable. It's like a cycle. Why? Ozone split into O2 and nascent oxygen. What is nascent oxygen? O, only O. Again, the ozone combines with the nascent oxygen, it will form O2 again. So this cycle will continue. So the rate depends upon the slow step. So how many reactants are in the rate? Can we write the rate law? How we can write the rate law? Rate is equal to rate according to the rate law. Rate is equal to K into concentration of the reactant. Which step needed to take? First one is fast step. The second one is slow step. Only need to take the slow step because it is a rate determining step. Okay, clear? So which is the rate determining step? The second one. So how many reactants are there? Two reactants, one O3 and one O. So O3 concentration of O. So this is the rate of the reaction. We can write the rate law like this. Rate is equal to K into concentration of O3 into concentration of O. Got it? Next one. And what will be the order of the reaction? What will be the order of the reaction? You know the order of the reaction here? In this, there is a slight change in the order. We will write 1 plus 1, it is 2. No, it is actually a first order reaction because as O, we can write like K into O3 by O2. So the rate become O3 raised to 2 O2 raised to minus 1. We can substitute like O3 raised to 2, O2 raised to minus 1. So the answer will be 2 minus 1. So it will be equal to first order reaction. Okay. So how we can write? We can just substitute like O. How we can write O? O equal to K into O3 divided by O2. Why? Because O2 plus O is what? O3. That's why just rearranging the equation, we will get O equal to K into O3 divided by O2. Okay, so just rearrange and we take the O2 to the numerator. When we are taking the O2 to the numerator, it will change into O2 raised to minus 1. O3, 2. O2 raised to minus 1. So what will be the answer here? 2 minus 1, the answer will be equal to 1 is the answer. Clear? Got it? Okay, the next one. Zero order reaction. Zero order reaction, the rate of the reaction, the concentration of the reactants, we can write like dx by dt equal to K. Then integrating the final equation derivation, sometimes it can be asked for 2 mark. For last years, it is not there. They are directly asking the problems and the final equation. So from the zero order reaction, we can write the rate x is equal to kt plus c, where c is the integrating constant. Okay, clear? So for a zero order reaction, the concentration of the reactants is equal to minus dx by dt, directly proportional to the concentration. So for example, if it is A gives P, how we can write dx by dt is equal to concentration of A raised to 1. So that means like this, minus dx by dt equal to K into concentration of A raised to zero order means raised to what? The power will be equal to what? Raised to 0. So we can write it is equal to K only. So integrating, we will get, on integrating this equation, integrating integral dx by dt. What is integral dx by dt? It is x only. So we can write x equal to K t plus c. T. Take this t to the opposite side like this. Integral K dt. So it will be equal to x. This is the final equation. X equal to kt plus c is the final equation for the zero order reaction. Then when c is equal to 0, when concentration is equal to 0, what will be the change in the equation? Then x is equal to k into t when c equal to 0, integrating constant. C equal to 0, we can write x equal to k into t. Therefore, we can find the k x by t is the value. And what is the unit for this? Mole, liter raised to minus 1, not time raised to minus 1. It is wrong. Mole, liter raised to minus 1, second raised to minus 1. You can use second raised to minus 1. So this is the unit for zero order reaction. That is very, very important. Just learn the derivation and the unit. And for zero order reaction, the unit will be equal to mole, liter raised to minus 1, second raised to minus 1. Okay, then next one. Examples of zero order reaction, H2 plus Cl2 gives 2HCl. Photochemical reaction. Next example is N2O. N2O decomposes into nitrogen and oxygen. Then over the platinum, it is happening with the help of the platinum catalyst. Then ammonia, Haber process, the production of ammonia we already learned. The opposite, ammonia can be decomposed into nitrous and hydrogen is the other example. Then CH3CO, CH3 plus I2, it will form CH3CO, CH2I plus HI. So these are the some examples for the zero order reaction. Learn this, it can be asked for your MCQ and for your 2 marks. Okay, then next one. Iodinization of acetone that we learned, CH3CO, CH3 plus I2, adding iodine to acetone, and enzyme catalyst reactions. And features of zero order reaction, the concentration of reactant decreases with time. The concentration of the reactant is decreasing with time. That means AT equal to A0 minus KT. What is it? Initial concentration, final concentration, and KT. So the rate is equal to K at all concentration. T half is proportional to the initial concentration. Hence, the rate and concentration of the reactant do not vary with time. Okay, that is the main point. The rate and concentration of the reactant do not vary with the time. And first order reaction, for a first order reaction, what is happening here? T is the time period, K is the rate constant, A or N0 is the initial concentration, and M out left after the time T. You can write AT and this one A0. So what will be the final equation like this previous one? And these are the example for first order reaction. Just learn 2 or 3 reaction like H2O2, it will forms H2O plus half O2. Then NH4 NO2 N2 plus 2 H2O. 2 N2O5 gives N2 NO2 plus O2 decomposition reaction. All radioactive integration disintegration process are examples of first order reaction. And first order reaction, the unit is second raised to -1 and does not depend upon the concentration unit, does not depend upon the concentration unit. It's only depending upon the time. That is very important. It's only depending upon the time. So T half does not depend upon the initial concentration. It depends upon the rate constant. So T half, half-life. How we can calculate the half-life? Half-life is given by 0.693 divided by K. 0.693 is a constant value. K is a rate constant. T half is a half-life. Okay. Hello. Then next one, and this is a graph of the first order reaction, log 10 versus the time. Slope is given K minus K by 2.303, and zero order reaction is also given. For a zero order reaction, a constant rate is independent of the concentration of the reactant. Rate is equal to K, and this is the graph for the zero order reaction. And when time in which the half of the initial amount is left, that is half-life. What is half-life? T half. T half of the initial, the time in which the half of the initial concentration is left is known as a T half. It is given by T half is equal to A0 divided by 2K. Initial concentration divided by 2K. Okay. What is A0? Initial concentration. Proceeds as a rate that depends linearly only on one of the reactant concentration. 2.303 by T log A0 by A. Then next one is the second order reaction, the last one, the second order reaction. The second order reaction, a chemical reaction in which the rate of the reaction is determined by the concentration of 2 chemical reactants. What is by second order? There will be minimum how much? Minimum 2 reactants will be there, and the concentration is depending upon on the 2 reactions. If it is depending on the 2 reactions only, it will be what? A second order reaction. The power, sum of the power of the reactant should be equal to 2. Which involves the rate of the concentration of the 2 chemical reactants involved, or the square of the concentration of 1 chemical reactant. And this is the graph of the second order like this. T half graph is given and the time 1 by 80 graph is also given. Know this one, and this is also important. Okay. And what is the unit here? And the other one is pseudo first order reaction. What is by pseudo? Pseudo means false. Actually, they are not first order reaction, but they follows first order reaction. Seems to be first order reaction, but they are not what? First order reaction. That is not a pseudo first order reaction. If the concentration of a reactant remains constant, because it is a catalyst or it is a great excess with respect to the other reactant. For example, we are taking 2 reactants. One will be very excess, or one will be in excess quantity or greater quantity, and the other will be in lesser quantity. In that case, or one is catalyst, one is acting like a catalyst than the other. In that case, what we will do? The concentration can be included in the rate constant. That means the concentration of the reactant remains constant, obtaining a pseudo first order reaction. For example, the hydrolysis of sucrose in acid solution. Sucrose we know C12H22O11. Hydrolysis means adding water. So we will write like what is the rate of the reaction? Order. We can calculate K rate is equal to K into concentration of this one, concentration of sucrose, concentration of water. Power term, that means 1 plus 1, we will write like what? Sucrose are true, rate of the reaction is third order. It seems to be what? Second order reaction only. Not third order, second order. So, but it is following what? First order. Actually, in this, we won't take the hydrogen concentration. Yes, pseudo order I am repeating. Pseudo order reaction means the reaction seems to be first order, but it is not actually the first order reaction. It can be second order, zero order reaction, but it seems to, or it tries to follow the first order reaction. Pseudo means false reaction. It is not actually what? A first order reaction. It can be second order or any other orders. But here, just look at this example. We are taking sucrose reaction with water. That means the hydrolysis of sucrose and water to form fructose and glucose. C6H12O6 plus C6H12O6. So we have two reactants and we will write the rate law like concentration of first term. Which is the first term? C12H22O11 and concentration of water. Here. What is the power? Raised to 1. So we can write 1 plus 1. It seems to be what? It seems to be second order. And if we are adding hydrogen, acid, it seems to be what? It seems to be third order. But I am not taking acid here. Now look here. 1 plus 1, it seems to be second order. But this reaction is not actually second order. It is following the first order kinetics. That means actually it is a second order reaction. But it follows the first order kinetics. That means a false reaction. A pseudo first order reaction. Clear? So the reaction is a pseudo first order reaction. It follows the first order. Then in second order reaction, there are examples for second order reaction like 2Cl2 gives 2Cl2 plus O2. It's very easy. Like for example, 2Cl2, another reaction. This is not pseudo. Okay, just example for the second order reaction Cl2. So in this reaction, here O2 is not there. Okay. Here, how many reactants are there? 2. So we can write the rate is equal to K into concentration of Cl2O raised to 2. Look at the power, sum of the powers of the reactant terms. It is 2. 2 means what? It follows the second order kinetics, so it is a second order reaction. So like that, we can find the second order reactions and note the some examples for the second order reaction. And the unit is mole. Liter, mole raised to -1, second raised to -1 is a unit for the second order reaction, and T half is inversely proportional to A. That is the concentration, initial concentration. Third order reaction is not there. Pseudo first order reaction are the reaction. This is a definition for you. Pseudo order reaction. Pseudo order reaction are reaction which are not truly the first order, but under certain conditions, this tries to follow the first order reaction, and here the molecularity is more than 1. Molecularity will be more than 1, but the order of the reaction is always 1. And just example, just look at the example, is very, very important for a pseudo reaction. It won't be 1, but it tries to follow the first order reaction. The molecularity won't be 1, but the order will be 1 only. Okay. Then next one is the hydrolysis of ethyl acid. It's an example that we have done now. Like we have taken the hydrolysis of sucrose also. Here we can take the example for the ethyl acetate CH3CO C2H5 plus H2O, and it forms acetic acid and ethanol. And we can write the rate constant like K equal to 2.303 divided by T log V minus V0 by V minus Vt. Clear? Got it? Yes, order 2. Sum of the power of the reactant concentration. Yes, very good, very good. Hydrolysis of sugar is also a pseudo order reaction. This we have done now. And methods of determining the order of a reaction. The order of reaction can be determined by these methods like initial concentration method, integration method, and graphical method, and half-life method. And we can use any of these 4 methods, and we have learned the half-life method and the integration method like the zero order, first order, second order by the integrating method, right? This one is not required. Then photochemical reaction, you know what is photochemical reaction? The reaction happening in the presence of light, that light energy is converted into chemical energy, or the vice versa, chemical into light energy is known as photochemical reaction. And for the example, if we keep silver chloride, or what happens when we keep the silver chloride or silver in brown bottles or medicines in brown bottles, it will absorb the light energy and it undergo decomposition reaction in the presence of light, and that kind of reactions are known as what? Photochemical reactions. So in the case of photochemical reaction, only in the presence of light it will take place, photosynthesis, formation of HCl. So for such reaction, delta G, the standard Gibbs energy, can be positive. And for example, synthesis of carbohydrate and HCl formation, red light has lowest energy. Some photochemical reaction can be initiated by the red light. Such reactions are not affected by the temperature, however, they are affected by the intensity of light radiation. And the retina in the eye undergoes geometrical isomerization by the absorption of photons of light to enable sight. This is for the NEET syllabus. I just added this one. Okay, is that clear? For the NEET. And this is also for the NEET one. What is luminescence? And it's the emission of light by unaccompanied by the heat. Emission of light, that is luminescence. We know bioluminescence shown by the like fireflies. Elementary reaction, that means the reaction taking place only in one step. Complex means taking place more than one step. Okay, clear? Got it? Then next one. Chemiluminescence, the conversion of chemical energy into cold light energy. For example, fireflies, the light emitted due to oxidation of luciferin protein by the enzyme luciferase. Actually, it is not coming for you. This is for the NEET and JEE syllabus. I just added the slides here for your reference. You can refer these slides from the note session. And fluorescence, you know the emission of light stops instantaneously when the radiation being projected on a fluorescent substance, it is cut off. For example, CF2, zinc fluoride, silver fluoride, they can show a color when a particle strikes on it. Okay, clear? Phosphorus, that is also the same thing. So in the last, I have given the important graphs that we already discussed from the beginning. Zero order, then first order graph is that is very, very important. You need to learn this for your boards. It's a sure question. Okay, zero order reaction, then first order reaction graph, then next one is rate versus concentration, second order, third order it is not there, but you can refer the third order also. Then next one is a rate integrated equation for a zero order. The graph is like this, first order, second and third is given, then half-life versus concentration, T half versus the concentration graph. Then we learned the T half is equal to what is the T half value, 0.693 divided by K for the first order reaction. Like that, T half graph is also given, and this can be asked for your MCQ. This graph depicts which ones. Like that, they can ask the question. Then next one, same thing, second order, third order. So these are the main topics we need to learn from the chemical kinetics. So if you have any doubt, you can ask in the comment section. So we completed this chapter with completed many questions related to the order, molecularity, first order, zero order, second order reactions, and the graphs are very, very important. Just refer the notes. You will be getting the notes by one link is there. You can enroll in the link and you will be getting the free notes, the lecture notes from that link. Okay. So we can wind up the session. If you have any doubt, you can ask here. Collision theory means what? When molecules collide with each other, what will happen? When we increase the temperature, the molecule starts to collide with each other, and when they will collide with each other, the kinetic energy increases. That is a collision theory, and they will form the product. Okay, got it? So these are the main topics that can be asked for your boards from this third chapter, chemical kinetics, and we can come with the fourth chapter, that is, which is the fourth chapter, D and F block elements in the next class. Till then, signing off. Bye bye. Good night. Thank you.